NASA deliberately crashed a $300 million spacecraft into the asteroid Dimorphos, which lies about 9.6 million kilometers away from the Earth, with a speed of about 22,500 kilometers per hour, and that made us think, why would NASA do something like this, especially during a time when NASA needs to focus on putting humans on the Moon and Mars? Well, to answer this, you need to look at some of the ancient objects of the solar system, the asteroids. Have you ever thought about what would happen if an asteroid might crash into our planet? Will it cause a mass-level extinction event similar to what hypothetically wiped out the dinosaurs? Well, we've got the answers for you, so keep watching till the end to know the bigger picture of NASA's decision to crash a spacecraft. Asteroids have always been one of the most fascinating topics when it comes to discussing our beautiful sky. The most famous asteroid we know might be the one that crashed into the Earth millions of years ago, which caused the extinction of the dinosaurs. If you're new to the term asteroids, well, these are rocky celestial bodies that orbit the Sun and are much smaller than planets. There are thousands of oddly shaped asteroids in the asteroid belt located between Mars and Jupiter. The asteroid belt could be as a result of residuals from a planet formed due to Jupiter's close-up force, or left over from a planet that was shattered by a collision. Today, we do have the technology to monitor several things that pose a threat to our planet. It could be climate change, solar flares, and even natural disasters. But an asteroid impact is something that we know very little about. It's not uncommon for asteroids to hit the Earth, but at the same time, it's not as common as you think. After spending more than 10 months flying in space, NASA's Double Asteroid Redirection Test, or DART, which is by far the world's first planetary defense technology demonstration, successfully reached its asteroid target on the 27th of September 2022. This is the agency's very first attempt to move an asteroid in space. Now, why is this significant? During the early days of space exploration, asteroids were ignored in the favor of far more glamorous planets and the Moon. But the truth is, asteroids do play a crucial role in the future of our species. In fact, the survival of human beings might be tied up with asteroids. Asteroids hold the hidden clues that might lead us to the very beginning of our solar system, even before our planet came into existence, and how we got here and what our future is going to look like. Asteroids might also have several untapped resources that might lead us to a future without scarcity, and finally, a single asteroid might be powerful enough to wipe out the entire human race. NASA and several other space agencies are spending millions of dollars for studying the cosmos. But it's also equally important for us to protect our home planet, and that's exactly what NASA is trying to do with DART. The DART represents an unprecedented successful planetary defense. This is also a mission of unity, with the real benefit for the entirety of humanity, according to NASA Administrator Bill Nelson. DART targeted the asteroid moonlet Dimorphos, which is a small body just about 160 meters in diameter. It orbits a larger 780-meter asteroid called Dimorphos. What's more surprising is the fact that both of these bodies pose zero threat to our planet. So why did NASA spend all this money to reroute an asteroid that is in no way a threat to our planet? Well, the agency might have a bigger statement to prove, and that is the need for planetary defense technology to save our species from an extinction event, so that history does not get repeated from what we learned about the extinction of dinosaurs. The investigation team will now be observing Dimorphos using ground-based telescopes to confirm that the impact of the spacecraft altered the asteroid's orbit around Dimorphos. Researchers are expecting the impact to shorten Dimorphos' orbit by about 1%, or roughly about 10 minutes, by precisely measuring how much the asteroid was deflected from its original path. This is also the primary purpose of a full-scale test. The spacecraft's sole instrument, the Dimorphos Reconnaissance and Asteroid Camera for Optical Navigation, or DRACO, together with the sophisticated guidance, navigation, and control system, works in tandem with small body maneuvering autonomous real-time navigation. This is what enabled DART to identify and distinguish between two asteroids targeting the smaller body. Now the size of an asteroid can vary from 10 meters all the way to 1,000 kilometers wide. The biggest reason why asteroids attract scientific attention is because of the possibility of having relatively unchanged remnants of the solar system's formation process about 4.6 billion years ago. With an asteroid hitting the Earth, dust and smoke rising in the atmosphere will prevent sunlight from reaching into the surface of the Earth and can cause the entire temperature to go south. This can also lead to the death of many living beings. If an asteroid the size of an apartment hits the Earth, it could also destroy a small city. Let's say that if the asteroid is the size of a 20-story building, it does have the ability to completely flatten a small country. Scientists are now actively trying to work out how much danger we might be in from future asteroids and what exactly we can do to prevent considerable damage to our planet. As of now, we don't know any known asteroids that might pose any significant threat to Earth, even though in late March 2021, one of the largest and best-known asteroid, Apophis, was on a possible collision course, but it was ruled out as being a potential danger for at least 100 years, all thanks to better pinpointing of its orbit. NASA's DART impactor spacecraft is receiving almost all of the attention, but it is NASA's CubeSat satellite, Lycia Cube, that performed the crucial task of giving us the pictures of the crash, which did not receive much attention. So what exactly is Lycia Cube? Well, it is also known as a light Italian CubeSat for imaging asteroids, which was launched from Earth alongside the DART impactor. The CubeSat was given the important task of capturing all the pictures prior to the collision and then flying away and taking pictures of the wreckage left behind. Just 3 minutes after the impact, the CubeSat was able to take and send images. The spacecraft ejected the CubeSat just minutes before impact, and that's exactly how we got the images. There are 2 cameras on CubeSat that are capable of producing comprehensive images, which will help NASA gather essential information regarding the crash. These cameras are designed to take an image every 6 seconds until the impact, and during its flyby of the asteroid, the Lycia Cube was tasked with taking 3 high-resolution images focusing on the asteroid, the impact, and the debris left behind. During the flyby, the Lycia Cube was also made to visit the other side of the asteroid and then take images of the same, something the DART was never able to see. Both the James Webb Space Telescope and Hubble Space Telescope also captured the views of DART spacecraft intentionally smashing into this asteroid. NASA also stated that observing the DART mission impact with James Webb was quite a challenge because the asteroid Dimorphos moved at a speed 3 times faster than the original speed limit of the James Webb Space Telescope was originally designed to track. The Hubble Space Telescope, on the other hand, had captured images after 22 minutes, 5 hours, and 8.2 hours right after the impact. The photos, taken from the Hubble's Wide Field Camera 3, shows the impact of the mission in visible light. What makes things even more special would be the fact that it was for the very first time both of these space telescopes were assigned the same target to observe, which makes things a lot more interesting and allows us to show that these telescopes cannot be replaced by the other. Instead, the James Webb Space Telescope is here to improve on what we already know about the universe, but this time the telescope will be studying the cosmos in infrared. Our space is extremely hostile to support life, and it can also put an end to our life on our planet. It's crazy to think about the probability of life existing in the universe with all these unfavorable conditions. So it makes a lot of sense to have some level of defense mechanism to protect something as rare as life on our planet. Hundreds of meteorites reach the surface of our planet every year, but most of them are too small to cause any damage, so you don't have to worry about any damage it would cause to our planet. Maybe in the future, these asteroids might help us to make humans a multi-planetary species, all thanks to asteroid mining for us to gather the resources that we need to survive on other planets. We haven't reached that point yet, but soon we might, and that's a piece of positive news. We are all eagerly waiting to see what the James Webb Space Telescope and the Hubble Space Telescope, along with other ground-based telescopes, have to offer, as these telescopes will help scientists to gain knowledge not just about the surface of Dimorphos or how much material was ejected as a result of the collision or how fast it was ejected, but a wider view of the cosmos that we know very little about. Ultimately, this mission was all about showcasing our abilities to deflect an asteroid in case we face an asteroid threat in the future. This mission could be our very first significant step towards the creation of a workable planetary defense system against these rogue asteroids.